Got an interesting problem here where we have a parallelogram and we want to find the values of x and y, and we're given some statements. So what we're given is we're given ES, so from here to here, is 5x plus 11. And then IS, so from here to here, so from this corner to the middle, is 6y. And then we have CS, so here to here, so from this corner to the middle, is y. And then I'm trying not to mark it up too much, but I guess I'll start just writing some things in. So this is 5x plus 11. And then SI or IS is 6y. And then CS is y. And then SP or PS is 3x over 2 plus 1/2. All right. What's interesting about this is you got to know some information about parallelograms in order to hopefully piece this together. And the first piece of information you need to remember for parallelograms is that the diagonals, so let me erase some of this marking here. The diagonals bisect each other. So this one and this, they bisect, meaning that this is congruent to this, and this is congruent to that. So that means that ES is equal to SI. I guess I should probably say IS. And then CS is equal to PS. So we have that. Now let's just generate some equations here and see where we can go from here. So I'm going to say 5x plus 11, because that's ES, is equal to IS, which is 6y. And then CS, which is y, is equal to PS, which is 3x over 2 plus 1/2. All right. So now I've generated pretty much a system of equations. So what I can do then is I can solve it, because if I can't just, like, if I'm looking at this one, 5x plus 11 equals 6y, I can't just solve it and get a single variable like y equals 5 or x equals 3. Like, I can't do that because we have different variables. We have an x and a y. And in this one, I have a y and an x, same thing. I have different variables, just like how we would in like a system of equations, so I could solve this. Now, luckily, we're given CS as y, and that's equal to 3x over 2 plus 1/2. So I'm just going to substitute that in and then see what happens. Like, let's just, if there's not like a rule book here, so let's just see what happens and see if something nice works out. So I'm going to have 6 times 3x over 2 plus 1/2. And there's not like a way you have to absolutely solve it. This seems logical, so I'm going to go ahead and substitute in. So then I'm left with 5x plus 11 is equal to, so we're going to have 6 times 3x over 2. So 6 divided by 2 is 3. 3 times 3 is 9, so 9x. Plus 6 divided by 2 is 3. Then I'm going to subtract 5x. So I get 11 equals 4x plus 3. I'm going to subtract 3. 11 minus 3 is 8. So I get 8 equals 4x divided by 4. X equals 2. All right, cool. We have an x value. That works nicely. So now I just got to get a y value. So I'm going to go ahead and substitute it back into here. So y equals 3 times that x value of 2 divided by 2 plus 1/2. So y equals 3 times 2 is 6 divided by 2 plus 1/2. Y equals 6 over 2 is 3. 3 plus 1/2 is going to be 3.5. So that means our x value is 2 and our y value is 3.5. So let's just check it. I mean, I don't think it would be the worst idea in the world to check, just to make sure that we do get equal statements when they should be. So we're saying ES is equal to IS. ES is 5x plus 11. So that's going to be 5 times 2, right? Yeah, 5 times 2 plus 11. So that's going to be 10 plus 11. Which is 21. Okay, so what we should get for IS then is 6 times 3.5, which is 21. So there you go. ES and IS are equal to 21. So we've successfully solved for X and Y. Yeah, so the property you need to know there is that the diagonals on a parallelogram bisect one another. In a parallelogram, that means the opposite sides are parallel. So this side and this side are parallel, and these two sides are parallel to one another. So we have this property where the diagonals bisect one another. There are times where the diagonals are going to all, like these would be congruent, this would be congruent, and then also these would be congruent too, like where they'd all be the same. I don't want to say that always going to happen. I don't think that's a safe assumption to make, but maybe in this case it would be, which I don't think it would actually, because y is just, CS is y, which is 3.5. So that's definitely not going to equal 21 because it's just y. But sometimes that will happen, but in this case, we don't want to assume that ever. All we know for sure the property is that the diagonals bisect one another. So that's what we have to go off of. But there it is.